All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our corrective measures module. Let's have a look at what we went over today. And yesterday, if you recall, we went over the process of batching our new complex models, and we started the process of training that model. So let's pick up where we left off. So with all of that, we've batched our data, and we're ready to train it. First, we will reuse our functions that we use to batch our data to run our validation. This is how we will run a validation with our new algorithm. So we have our val data set equals tf.data.dataset dot from tensor slices x val y val. Now that our data has been validated, we will test it using the same method as the last two processes. Let me actually start compiling now. Sorry it took so long. And now we will test that data. So this is how we're going to run a test. This is how we're going to test our new model. Is test.data or test underscore data set equals tf.data set from tensor slices. It's all actually the same algorithm. We're just changing out the variables here. So we have the val data set, the test data set. Now these are the steps we need to take to convert this data set up so that we can work with our TensorFlow data API. We won't do any modifications on this data. It's going to run it as it is. Now all we need to do is specify train data set, and then we add our val data set. We can do that like this. So we have our history equals model.fit, train data set, validation data equals val data set. Epochs are still 100, and reverse is still 1. Now next we'll run a new plot for our train data set, model loss value. And this is how we're going to do that. It's the same way, like I said, it's the same way we run the plots before. It's just we're going to put them underneath our new information so it can capture the new model information instead of the old model information. And then we're going to do the same thing for our root mean squared error. Now, once all of this stuff runs, I'm going to get and show you exactly what it looks like and the big differences. Let me see. Let me show you that in the data preparation file also, where we moved everything over to. So you can see our data preparation file is set up for all the new stuff. This was yesterday here, how we ran everything, how we batched everything. And this is how we're training our data here. So we have a validation data set, our test data set, and here's the history of it. And then these are our plots underneath. And then we're going to actually evaluate that information once everything runs. So yeah, once everything compiles, I can actually walk you through it. And I can show you the differences between the plots, the drastic drops in numbers. So these are the original plots here. Let's get those out the way so you can continue compiling. And I do want you to focus on not the last set of plots, but the plots that I showed you before with the original complex information. I want to show you the drastic drop in numbers and how much that complex model actually improved after we retrained everything. So I believe this is the second set of plots coming up soon. As soon as we get through this, tick tock, tick tock, tick tock, tick tock. And again, when you're dealing with large sets of data, of course, it's going to take a while to compile through everything. So it's best to just be patient and start compiling as soon as you can. Okay, these are the second set of plots we're going to pass through. Now it's the plots after this I want you to pay attention to. This was the original complex model before we actually retrained everything. So this is just making it more complex. I want to show you what these models look like, or remind you what these models look like. Tick tock, tick tock, tick tock, tick tock, tick tock. Okay, so look, notice our starting numbers here are 140,000. Remember that number? That's for the model loss. And then we're at 200,000 for our model performance. So this is just the complex models. We didn't retrain them yet. Now I'm going to go through the retraining processes now. This is our bar graph. It was just charting information we already knew. So now we're going to start going through the new information here. Tick tock, tick tock, tick tock, tick tock, tick tock. Okay, now look at our new model loss plot here. So we're starting at around 42,500, and our plot is actually, or our train data is actually picking up at around 33,000. So you can see it's a huge difference between starting at 140,000 and then 42,000. So making our models more complex and then actually training that data actually improved our models drastically. And this was the model loss version right here. So you can see, let's look at the root mean squared error. 50,000 compared to the 200,000. So again, making that information more complex and then retraining it and then replotting it was a huge difference. Now our values are way closer to actual values or estimates predictions for those car prices. And then we're going to do the here we see here we have our, what was this here? This was the evaluation of our actual information. So like I said, it's going to be different every time. So the first time I ran it, I got 39,000 back as the lost value, and then 48,000 for the root mean square error. Still in the same ballpark, but yeah, notice that this isn't actually very different from what we had previously, and we may feel like this is producing a different plot because of the drastic changes. But the model in its current state already had a loss of around 30,000, as opposed to the 150,000 from our previous plots. So the plots may seem like they're different or they're picking up different data, but they are the same plots. It's just that the drastic change has come from making our model more complex and actually retraining that data. So yeah, that's what we spent doing all morning, and we're going to keep moving forward. And I'm going to keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.